Can I ask one question?
Yeah.
Can you, when you...
Hold it. You interrupted the thermal guy. He's already told you.
I am so used to it.
It just continues, okay?
I'm so sorry.
All right,
We are
so
the bottom of the
sorry.
food chain.
I'm
Okay?
so sorry. When you introduce yourself, can you tell us what type of engineer you are? Because one of the things that we're doing for next year, is we're trying to partner with NASA, is we want our students to know the different types of opportunities they have as far as in the workforce. So for me, it'd be great for me just to hear it, so it can register for me.
Yeah, I'm going to suggest we move to the table.
Yeah,
That way you
sure.
won't be freaking out.
Try not to notice me.
Okay, well, I'm Jeff Farmer. I am PhD in mechanical engineering. Have been in some aerospace background, a number of years working with NASA. But I may have been a manager too long to really be a good engineer. But at least I'm here. Well, I guess one of the things that I do is the heat transfer, spacecraft thermal control, which for CubeSats is one of the I don't know. It's often not looked at until it comes up and bites you. The CubeSats really don't have a lot of surface area to be able to reject heat to space, but they cover their entire surfaces with solar arrays. So there's really not a good way to lose heat, or you can lose too much heat, and now you need extra extra solar arrays to provide all the power for the electronics and to keep the thing warm. So there's just a balancing act particularly for CubeSats. You're limited in what you can do and so forth. But again, that's one of the things that we struggle with, because a lot of the other requirements, the sensors, the power, the comm, the GNC, it all kind of needs to come first. Anyway, what other kind of information, introductory kind of statements do you need as far as?
Oh, that's you said mechanical and aerospace.
Mechanical and aerospace. Structure. So in my department, we have the structures guys, we have thermal guys, meaning structural design and analysis and fabrication, and we have the thermal engineering, which is heat transfer, thermodynamics, various flavors.
So when you design, is there a time when you would design something and you send it to the the heat, the thermal people? Do they shoot down the design and say we can't cover that?
We do sometimes.
Okay.
But what you really want to try to do, I guess, is get as much of your payload requirements up front, and then you establish what your spacecraft requirements are at that point. And at that point, then most of the subsystems, structures, electronics, etc., sort of go in parallel. Okay. You hope they communicate with each other, so it's not like you wait until the end to get to thermal. It's just sometimes the thermal considerations aren't really listened to until the end.
Okay.
Preferably you want to hit them all at the same time, and so that everybody can interact with each other and figure out, well, you really ought to do this or do that. And you saw some of those questions when we were looking at camera resolution versus controllability versus data storage and comm, and all that stuff starts to play in. So you need to handle them all together as much as possible.
Thank you.
My name is John Seschel, mechanical engineer, master's, and I'm in the structures and mechanism, same division as Jeff.
So I'm Delisa Wilkerson. I'm the branch chief for the electronics design branch. So we design all the electronics that go into a box, analog, digital, power, whatever you want to think about. We don't do the sensors, we don't do the motors, we do the interfacing to all of that. We don't do the software, but we provide the hardware for the software to run those. I have a double E degree from Tennessee Tech. I worked in Oak Ridge for a while, and I have family in Oak Ridge. My cousin's a teacher there too.
Who's that?
Longer.
Oh, yes. We all know her.
Does
So,
That's wonderful. Yeah.
Does that include networking, like
Yeah.
on satellite network communications? Is
Yes.
that part of your?
I
area
don't-
as well?
That's right.
the RF, so the communications down to the ground, that's a different group, 'cause that's a different speciality. But internal communications, yes, your data buses and everything and how things talk together is great. The one component I saw that you might be missing is somebody looking at the whole structural area. And you're gonna have some internal connections that you're gonna have to look at, internal cable harnesses and different things like that, so, I didn't see that.
Basically mechanical design, is that what you mean?
Well, more from, where we put our electronics together design, but I also didn't see the mechanical
Right.
design of the structure either, and and like I said, it is a system, all pieces play together, so you really have to think of it that way and not let people isolate out into groups, otherwise it won't come together.
So when you go in commercial off the shelf, a lot of things follow the same standard, everything's plug and play, but the cables and where things fit, making sure you have room for everything, it's a big deal. So it might fit fastener wise, but you can't have the cable coming out right in front of the next component.
Yeah.
Tight bend
Sounds like
radius.
experience.
Yeah, sore subject.
As far as data interfaces too, from components, so you get a commercial component and it has a
Right.
particular type of data interface, and you have to then send that into whatever your controller, microcontroller is, and that board may not support that many different, say, RS-422 type interfaces, and now you've got to work at how you're gonna accommodate that. So, it's pay attention to your interfaces.
Lee's a teacher in our building.
Oh, really?
She's a
Oh.
Robertsville teacher.
All right, well, I'll have to Facebook her and tell her.
I bought my whole house of furniture from her family also.
Okay, that's my uncle, Larry.
And they're gonna call her Leanne when they get.
That's right.
She goes by Lee, so
Does
yes.
she?
yes.
Well, I'm a cousin, I get that privilege.
Yeah, now we know the scoop.
And we do too.
My name is Todd McLeod. I'm the Deputy Division Chief for Systems Engineering in this building. In my education bag, I have electrical engineering PhD. I think systems engineering is trying to pull all the things together. I think that's going to be key for your people. You can have people go look at specific things, but they all have to come together, and people doing something over here affects people over here, and if they're not aware of it or don't see how it affects it, it's like the pointing system and the camera. They tie together a lot, and the analysis. What am I going to look at and analyze, and that depends on So I think right. So I think it's really important, and I think it's great. But as we've seen, satellites are really complex. There's all sorts of things, and there's 500 things, and if one of them isn't done right, then nothing works, right? So I think they give the best experience to the students. I think simplicity is going to be the key, and it'd be nice to have a super hyperspectral thing to go measure stuff, and that may be really good data, but if it doesn't work out, then I think they lose a lot of the experience. And so I think trying to have it really simple, pointing system as simple as possible, camera as wide as possible, data is low, stay with low data rates, and knowing that you only going to get data so often, kind of thing. Because I think that's the best experience is the overall experience, not I mean, it'd be nice to have really good data on something, but I think if you get general data on it, I think the experience of doing it is really good.
Listening to the groups, do they seem to be cohesive?
Yeah, I mean, I think they're really good. I mean, they obviously haven't done this a lot, right? So, but I think they, we're focusing at least on the things that are important, and at least understanding the areas that they've been looking at. Trying to pull it all together into a functional package is gonna be a challenge. It's a challenge for us to do, and it's gonna be a challenge for them.
We seem to understand that nothing's set in stone. Your headlines, there's a lot of changes over here, we have to change our stuff, so it's good.
The only thing that would add to that though is that, and I think I understand why it was done this way, but doing it with the 4 blocks, you have a touch of requirements in one, a mission in one place and requirements in another and something else in another, but yet you're still going through the blocks, block 1 through 4. Some of that story is maybe different than what we would normally think of at NASA. Normally when I see a story of a mission, I would think, okay, here's the mission, here's the requirements, here's the design, here's some of the pieces we're using, here's some of the issues we're trying to do. That kind of flow. And so you end up with some specialization going on, but you end up with a story that builds on each other. The kids were great. And I think by doing it the block way, you get the kids focusing on different aspects within it, which I think is important. But then you need to maybe another way to figure out how to tell the story when you're done, or when they're up in a group like this, to let it flow a little bit, at least for this environment. Maybe for the Rotary Club or some of the other things, it doesn't matter as much as far as the actual story like that.
These are things we want to hear because we're really flying blind. This is a huge thing to attend. So we're going to be a hot mess the whole way through.
Well,
And
that's
we're
okay.
with
Hot
it.
messes are fine.
Right,
They actually
yeah,
can be
we're a hot
productive.
mess and we're a middle school hot mess, which is really hot. So, we love to hear these things because, we came last year and I don't think we did a good job with conclusions last year. So, we tried to have specific cameras and specific packages because we tried to do the research that, and these topics were things that Patrick thought we should start with. And
Sure.
we know that we're young
Sure.
and we may not even make a proposal this year. We're going to move, our goal is to come up with an idea and propose it by, November, but if we decide we need to step back and look at this a little bit more, we're completely fluid with the process because, it is our first time and we're going to make all kinds of mistakes, but,
Right.
I
Well,
feel
I was-
like
But
we're-
I don't think you should look at it as being unbelievably daunting, stuff we deal with usually is like, hundreds of millions of dollars and really complex and stuff. But, the CubeSat world has sort of made it plug and play a little bit. You can make a fairly simple satellite with, it's definitely doable. Right? People do it. And so, motivated 7th and 8th graders can do it. And so,
One of the things that we have questions about is, and my mom names said keep it simple. I think keeping it simple is, that you don't have to make it simple. And it's not simple, right? Even if we do it simple.
That's right. That's what I mean.
But does that, is that fulfilling NASA's requirements? So how savvy do we need to be in our proposal? Is it enough to say, hey, NASA, we're in middle school, we're going to teach kids about satellites and sort of real world, how that comes together?
you're right.
Do you
Yeah,
have experience in that proposal process?
So, NASA's not expecting 7th graders to go solve
To do that
major
hard
things,
thing.
right? But at the same time, they don't want people, we're just going to play, right? And so I think what they want is the process more than the outcome. So if you come in and say, we're doing this, we're designing these, we're doing this, we're having these reviews, we're doing this, I think that to NASA is plenty. That if you go do that, and you need to be having your focus on your end item and how you're going to get there, but I don't think they're not going to judge you the same as Caltech in building your hardware, but you need to have what they really want is a process and not because I review all sorts of and some people just turn in some we think it's neat, we just want to play. It's like that's not really the point of this. We want people to go through and have a learning process and to have, you need a scientific goal, and that's part of the process and going through and trying to achieve that. But the actual goal and the probability of achievement isn't as important, as the process.
Yeah, because I didn't want to say to kids, I don't think you're going to get a picture of one, but I don't know the answers to
But
that.
you can, but you're not going to
Yeah.
get,
Realistic
you're not going to get
expectations.
1 meter,
Yeah.
1 meter resolution.
Yeah.
And you can, but
That's a
it'll be hard.
small target, and you're a 3. There's just not a lot of tools you can put in.
I think if
to
you,
make that happen.
the kids are excited
They
about.
are, and they love it, and it's their idea, so I don't want to be.
Yeah,
I think you can still make that basic idea work.
Yeah.
Right, and it's amazing that they have 3D CubeSat cameras, and you think, oh, I'm 200 miles away, but you can get a pretty good picture. I mean, it's not going to be Google Earth exactly, but a pretty good picture of, and I'd be excited if I put something up, and even now, took a picture and there's my house and there's my school. That's my thing.
But I think if you can get them through that process of, here's, we want to look here, okay, well,
What does it take to do that?
what do you need to see in order to, what is it that you're wanting to measure? What do you need to see? And then how does that translate then over into the hardware side of making that happen? I think getting them through those processes would be a huge learning curve and valuable for them, because that's the whole engineering process. I want to do this, but what do I really have to measure? And then, okay, I need this. Well, then how do I do that with these electrons?
But for me as the teacher, I just, if there is another process, another scientific method, or another scientific process that you think would be more doable for them, because the kids know, and we spent this whole year looking at stuff, and we would FaceTime with Patrick, and they would throw these ideas out, and I let them throw them out, because that's what they need to do. And he was interested in this because originally it was something that other science schools, science classes could look at as far as canopy growth. But I mean, we could look at CO2 levels. There's a lot of things we would look at, and they're good with whatever. They just want to go through the process. That's what they're excited about. They know that we can't really see a significant change in the canopy in the time that satellites. We've already figured that out. We know that. They know that it's not going to be up there long enough to really see trees grow.
But
So-
the other thing, what you may want to do is just, even though the Gatlinburg fire is local and important, I'm not sure how much data you get, but the Earth's big, and there's a lot of all sorts of things. I mean, if you talk to the severe people, there's all sorts of things all over the world, and your satellite flies over everything. So you can be taking pictures of things happening in Brazil or Indonesia or whatever, and those pictures are important too. You can go look at deforestation or floods or whatever. But I think imaging is probably the easiest thing to do that gives you really good return. So I think taking images, you can have like a little sensor measuring the magnetic field or something, and that may be simpler possibly, but I'm not sure that's very
As long as you
engaging.
say that's something that's good yet doable, then that's what we were
Right,
kind
but
of afraid of.
people make stuff so you can do it, so I don't think it's that.
So it's within the scope of what we can do to actually point and take.
Right.
That was our big question, our big technical question, is we know that this whole attitude control is central to being able to do anything with the camera. And we know about reaction wheels and magnet torquers,
Sure.
but we don't know if that's within our capability.
Right, my suggestion is try not to have reaction wheels. I mean,
Okay.
they make them, they're expensive, they're a problem. I mean, if you got to point well, it's good. But they have mag torquers you can buy for CubeSats. Some they included into the solar panels, and you can get a few degrees pointing capability, especially if you just try to point down. And that's probably the best thing to do, is point down. Nadir, as they say, right? And you'll be off you know, it'll wobble a few degrees, but I think that's fine. You'll get
I'd be
pictures.
so excited to have anything and
Right.
know where it is.
Right, and so,
Exactly.
and they have software routines already built to say, I want to point down and you know, they call it DDOT, which is.
Do you have my drones?
You know, or you
Drones
can
are
have it
better.
the simplest thing, you know, satellite, they just had a magnet in it and you nod with the magnetic fields. That's probably not what you want, because then you could be pointing straight to the side. That's the simplest way, but then you can have these magnetic torquers that, you know, they got software built in, you know, already built for them. They're not very expensive. You point within 5 degrees or so, and that's good enough.
Yeah. It's good to
that's,
hear.
that's control. How about knowledge? Directly in the sense that's what you're doing.
I think a wider field of view camera gives you a better chance of getting something that you can identify on the ground and therefore know where you're pointing.
Plus, you
Right.
don't have to have one camera. You could have multiple, right? You could have a wide field of view and a smaller one if you want to do it. I'm just saying.
Keep it simple.
We didn't hear from Kevin about his,
You get
introduction.
GPS,
Oh,
and you'll
yeah.
know where you
Make
are.
sure that we don't miss that.
Yeah.
You can
But you
buy
still
a
don't know where you're
GPS
pointed,
system,
right?
you know where you are.
No.
Because, you just encode that in your data coming down, so you get your picture, you know where you were. And if you know where you are and you're pointing down, you can, I mean, Severe has the same problem. The space station, you think, knows where it is exactly. But it has a lot, and so they take pictures and they think it's, you know, this hill in Afghanistan or whatever. But they're off, and so they have to go and figure out, well, apparently, really, it's tilted over some.
So the GPS is a lot though, right? So they need to detumble, and they need to know how to detumble.
Right, but you just get mag torquers, they do DDOT, they have software, they'll detumble, and you can have it, you know, they have a routine to say point A or point A.
That was my huge anxiety was just, you know, if we can't do that, then we have to pretty much abandon the imaging idea.
Right.
But if we can do that, that's really cool. Then we can proceed down that path, and then all the other design requirements kind of fall into place.
Okay, Kevin.
Yeah, I'm Kevin McCarley. I'm the systems engineer. I work in the same division as Todd. I'm an aerospace engineer by training at UT. Yeah. I was the only aerospace major in my graduating class at UT.
Wow.
At UT. Now, there wasn't mechanical, because mechanical get much more interviews. But I knew I wanted to work at NASA or something related to NASA. And I went to Oak Ridge High School and Jefferson Junior High School. And,
I went to Jefferson.
but it's not all that. And a lot of what we do in system engineering that Todd's already spoken to and Jeff mentioned as well is kind of helping the project team go through the process to get from requirements to design activity to verifying that your design meets the requirements, et cetera. And I think that's one thing you guys might want to think about doing is what, and you talked about the objectives. You know, number one objective is education. That's easy. You got that one. And I think being a middle school, that's going to look even better to the reviewer's eyes than a university.
We do, we're pretty sure that the middle school has an English.
I don't think so either. I just didn't
So
see.
no one elementary,
Yeah.
high schools.
A lot of universities, but none middle schools.
That's a big.
The other objective, your scientific objective, that's really going to drive the rest of your system, I think, because I think the idea of, well, imagery is very engaging, but we've flown cameras before, and even in this program, so you need to take it one step beyond just getting some imagery. Although the kids will love that, I would love that. Like not the same. But I like the idea because the Gatlinburg fire is very important and very topical and timely. But you probably need to broaden your scientific goal to include that idea, but to look at it at a global scale or a very related but maybe easier to grab the data to show goal. Because you're right, I mean, you might get imagery of Gatlinburg area. You've already taken a look at, we won't really be up there long enough to see the canopy change significantly, perhaps. You'd be flying over the rest of the world too, so what are you going to do during those orbits? So you might want to broaden your scientific goal, and I do think keeping it simple is really important. So I think imagery is doable, it's very engaging, but what do you use the imagery to show? And again, I think the basic idea is good and doable. You might want to broaden it a little bit to make it a little bit easier to do and not drive the requirements of your system quite so severely.
So if you flying directly or within a couple of degrees over some point like that, that probably only happens, no matter what orbit you're in, but probably only happens once every 4 days or so, so, and it could be night, when it happens, so so you could be, if you're in a sort of polar orbit, you fly over every day, over every place, but you're, so you have to have, realistically, you're only going to get once every week or so, you're going to have, a possible image of any specific spot on Earth.
That, for this study, that may actually be okay. But
Right, may be
but
okay.
The thing that we would be concerned about is how long can it stay up there? Can we get?
Right, so
at least
if you, I would imagine that they're off space station, they're not, these guys fly them to space station, so that's usually 9 months. So, hardly anyone puts up ones much lower than that, so it could be 6 months, but usually it's 9 months. It could be up higher, which could be a year or 2, and that is what,
Yeah.
how it drops you off.
So is that something that could be requested? Can we say we really need this altitude because we need this to stay up longer?
I don't know.
You
but I
can,
think-
but I wouldn't do anything that would make you less likely to
Yeah,
choose.
right.
Okay,
Okay.
Right.
I think what Kevin says is pretty doable. We can say Gatlinburg is our goal, and we're gonna look at Fire Scar, we're gonna look at.
Or you could
There
look
are
at other
lots of
fires.
ways.
There's,
Yeah.
people know there's 1,000 places that have big fires, and you can go look at, different lives. This happened a year ago. This happened 20 years ago. This happened last week, and you can have just different images and look at, and you might not be able to image individual plants, but you can take, especially if you look at the
Soil moisture or
right, no, but
ground
the
ground
spectral
material.
thing, you
Yeah,
say,
where you pick out,
I
like-
see these colors, and that indicates, you
can
guys
pick-
know this better than I do, right? Some sort of plant, this is this kind of plants, these are these kind of plants,
Well, we
and
can-
it would be, I mean, it's not new, tremendous breaking technology, but it's, for these students, it is, and it's real and it's important.
Or you could pick 20 fires that are each at a different stage.
Right.
And it starts to
Right.
tear
I
out.
think that's,
Right.
Yeah, in a different
Yeah.
climate, which, would make a difference on the growth.
Odds are you'll hit at least one.
well, you'll get 20 a day.
And part of your
Well, we can
presentation could be
broaden
your
our
map of the
application
fires you're
list
tracking.
to
Yeah.